Alrighty, here we go. Now we're going to do test video review number 3. Okay, so from what we have here, we're now going to be adding, subtracting complex numbers. So we're going to put here 8 plus 1i. So I'm putting these in like under, like terms, combining like terms. Thank you. I've been a little tongue-tied there. So anyways, negative 5 plus 8 is 3. Negative 4 plus 1 is negative 3. And again, like the way I'm saying these are the ways you could type them into the calculator. So like you could say negative 5 plus 8, and it would tell you 3. And negative 4 plus 1, and it would tell you negative 3 also. So then here, like this one, I would say minus 5. Because remember, when there's a plus here, we keep them the same. Plus 9i. 15 minus 5 is 10. 9 plus 7 is 16i. When you have the minuses, they're going to change signs, so we're going to say the minus 6 will become plus 6, and the minus 5i will become plus 5i. Negative 7 plus 6 would be negative 1, and then 5 plus 5i would be 10i. Okay, so there you go with that. And again, like these should be very simple. So here on the second one, I'm going to say minus 11. Notice how the signs are changing. Plus 13i. Now again, that means like on the calculator you would say 17 minus 11 is 6. Negative 8 plus 13 is positive 5i. Trust me when I say that on the test, I will have some that would say like, oh, negative 8 plus 13 is negative 21, because somebody is going to tell me that. And then I would be, no. Alright, so let's look at the next problems. Ooh, I somehow missed number 54. How did I do that? Okay, so let's look here, because I somehow did not get 54 in here. So let me put 54 here. Okay, so I have 3 minus 8i times 3 plus 2i. Okay? So what I'm going to do here is I'm going to go ahead and multiply these by the vertical method. And so I get negative 16i squared. 2i times 3 is 6i. Put a 0. 3 times negative 8 is negative 24i. And then 3 times 3 is 9. So we get 9. 6 minus 24 is negative 18i. And then here's this one. I squared, again, keep in mind that I squared is equal to negative 1. So instead of having here I squared, I can think negative 1. Negative 1 times negative 16 is positive 16. And then I can add those two and say 16 plus 9 is 25. Minus 18i. And there you go. That's your answer. Okay, so on this one, 7i times 7i, you get negative 49i squared. Negative 8 minus 3i. Negative I squared, or I squared again is negative 1. Negative 1 times negative 49 gives me positive 49 times negative 8 minus 3i. Multiply out, and you get negative 8 times 49. Okay, somebody needs to correct me sometimes when I'm like not paying attention. 49i squared times a negative 1 would be negative 49. I have no clue why I was thinking the other way around. Anyways, so 49 times negative 1 would be negative 49. So I should have negative 49. I have no idea what I'm saying the other way. Anyways, 49 times negative 8. Negative times a negative would be positive. 49 times 8 would be 72, carry the 7, 392. 49 times 3 would be 27, carry the 2, 147i. And there's your answer. Here, I'm just going to tell you the shortcut. The shortcut is you switch the numbers, 9 and 10, make sure the I stays there at the back, drop the I from the bottom. Now, the sign that you have for this one will change, so that negative 10 will become positive 10. The sign for this one will stay the same, so that was positive 9, it stayed positive 9. And there's your answer. On this one, that's like saying it's negative 7 plus 0i, 7i. So if you did the same principle, switch, you would have 0 plus 7i over 7, which is just 7i over 7. So you can kind of see here how the I moved up and changed the sign. So that's kind of a shortcut there, and that's kind of a couple of different ways you can look at it. I can explain it in different ways, but if you want, but you know, you just need to ask. Okay, so now we're to number 58, where we start doing square roots to solve. Okay, so keep in mind that all these answers should have a plus and minus in front. Okay, so now here, if I add 5 to both sides, so we're solving this, I get 2x squared is equal to 128. Divide by 2, I get x squared is equal to 64. Then once you're there, that's when you take the square root. And the square root of 64, according to the table, is plus and minus 8. That's it. You're done. But again, you have to have plus and minus. Okay, 59, I'm going to add 1 to both sides. I get negative 66. 6x squared is equal to negative 66. Divide by 6. I get x squared is equal to negative 11. And again, I'm going to take the square root. Now, when I have a negative, that means I have an I. So I have I square root of 11. And then if I look on my table, there's no number that will divide into 11, so then that's my answer. I square root of 11. But don't forget, what are you supposed to remember? You gotta put, oh, you thought I had forgotten, but I didn't. I plus or minus square root of 11. So you gotta have that plus and minus again at the beginning. And for those of you that are going to pick about my handwriting, there's that 11. Anyways, alright, minus 8, you get 7b squared is equal to negative 105. Divide by 7, you get 15, so b squared is equal to negative 15. Take the square root, and I get the same thing, that b is equal to plus and minus I, because there's that negative again, square root of 15. And there's nothing else you can do about that, because there is no perfect square that will divide into 15. Subtract 8 here, and I get 54. 6r squared. Divide by 6. R squared is equal to 9. Take the square root, and you get r is equal to, the square root of 9 is 3, but don't forget to put plus and minus. So, it's fairly simple. The idea is make sure you get the x squared by itself, and then you start trying to take the square root, okay? So how is 62 through 65 different? Well, they're different in the sense that once you have this perfect square, or once you have the square root by itself, you square. Because again, remember, square and square roots are opposites. Square 9, you get 81, and that's it. That's your answer, 81. Now, the two that pay attention to are 63 and 64. Those are very similar. Notice, this looks like the same problem, but different. Here, the minus 8 is on the outside. So then I need to take care of that first, because I need to have the square root symbol by itself. So plus 8 plus 8. Square root of x equals 25. And then square that. You get x is equal to 625. And you're done. Here, the square root is already by itself. The minus 8 is inside. So I got to square this, and I would get x minus 8 is equal to 289. Add 8, and x is equal to 297. Okay, so not too bad, not too hard there. Now here, 65 and 63 are also very similar, because here I had something on the outside and I got rid of it. Here I have a times 2 and I need to get rid of it. So I say 14 divided by 2 and I get the square root of 5, x plus 5 is equal to 7. Then I can square, and I get x plus 5 equals 49, because 7 squared is 49. Again, this is where that table could help if you want to make it a little quicker. And then you can subtract 5 to get x is equal to negative 40. Why am I saying negative? Good grief, I'm stuck on negative. Hoy, it's Christmas time, I shouldn't be so negative. Anyways, alright, so then I get 44. So there you go. So it's not too bad. You can see these are fairly easy. So we can kind of go through them. Alright, so now let's talk about domain and range. Okay, domain again is your x values. Range is your y. Domain is worried about left to right. So what's the furthest to the left I go? What's the furthest to the right I go? Range is worried about low and high. Okay, now if they are points, keep in mind that you need to list the domain and range individually. So like you have to label each and every single point. Okay, so list individually. Alright, so let's look at these and let's look at these problems. Okay, so what you can see here is like on this one, okay, when you don't see an arrow, we're going to presume that there's dots on the end. Now, I'll talk about what would happen if there had been arrows on there, so we'll talk about that in a second. But the domain here, the furthest I go to the left is -4, about. The furthest I go to the right is +4. So there's your domain. Your range, and the reason why we're doing like this is because that covers every point that's in between that. Okay, the range is the low and the high. If you look here, this one goes down here and up here. Now these are going by 2s. Look at the scale and it's going by 2s. So that means this is -18 to +18. So pay attention to the scale. Now, if I don't mention the scale, or if you don't see any numbers there, presume it goes by 1. Alright? Now, for the next part, if I had put these with arrows, okay, your domain and your range, in this case, would have said, okay, it's going on forever. Okay, it's going forever to the left, and it's going forever to the right, which is -infinity to +infinity. Same thing with the range. It's going forever to the left and forever to the right. So, and you could put all real numbers for that, but, you know, we could also put -infinity, +infinity. And I think on the test itself, I put -infinity, +infinity. Now, here's someone with points. When they see the points, you need to list them individually. So, 1, 2, 3, these are my x values. I don't need to write them again if they repeat. So 1, 2, 3, 4, and 5. The y values are starting at -6, -3, -2, 1, no, I'm sorry, 2, 2, 3, 4, 5, and 6. You have to list them individually when it's points, okay? So kind of keep that in mind. You want to make sure you choose the right one. Okay, so for this last one, let's go like this. Let's do this as if they were dots, okay? So my domain, furthest to the left is 0. The furthest to the right is 5. My range, it looks like, we'll say -2.2, and it goes up to 2.2. Okay, that's if I'm saying they're points. Now, if I had said these were arrows, so that way you can kind of see how it would be different if it was arrows. Okay. Here, the interesting part about this is, look, this still has a boundary here. The furthest to the left is 0. It doesn't go any further than that. But it goes forever to the right, so that means to +infinity. On the range, though, it goes forever down, and it goes forever up. So that's still -infinity, +infinity. So you kind of got to be careful with those, especially when they have like those zeros. Here, now I do have an arrow. Thank goodness I don't have to change that around. They finally got it right. Okay, but notice here, there's still that 0, but it's going on forever because that arrow says it's going to the right forever. So that's to +infinity. Then, the range, the lowest it goes is this 3. But this arrow says it's going to go up forever, even though it doesn't look like it, so that's to +infinity. So you can see here domain and range. Now, keep in mind, I'm supposed to also mention whether or not these are functions. Yes, this is a function. There are no points where they're over each other. No, this one is not a function. The reason why this one is not a function is that I can see I have at least 2 points that are on top of each other, which would say that x would repeat. Here, This one is not a function because, again, you can see you've got points where they're over each other, would fail that vertical line test. Here, this one is a function because there are no points that like kind of repeat, no x's repeating. So you can kind of see some of the differences there about what we talked about with domain and range and whether or not it is a function. And that's pretty much it, guys. If there's any other questions as far as regarding the semester exam, make sure you ask, because this pretty much covers the whole review. Thank you very much. Good luck.